Hello, Algebra. I hope you guys are doing great. The object for today is to learn how to factor trinomials whose coefficient in front of x squared is 1. And the other harder version is going to be the part of intermediate algebra, which is the next semester, so we're only going to cover these basic cases. Now, when we say trinomial, right, we are talking about ax squared plus bx plus c, and since we say a equals to 1, right, since a equals to 1, so this section is all about factoring x squared plus bx plus c. So this is what we are trying to achieve in this lecture. So far you know how to factor out greatest common factor. You know how to do factoring by grouping. Both of those were in previous section 6.1. And today it is time to look at factoring of a trinomial whose coefficient is 1, right? The leading coefficient is 1, which is the first and basic case. So we are looking into factoring something like this: x squared plus 5x plus 6, as an example. So we know what the goal is, right? Goal is to have two parentheses like this multiplied, and those will be factors, and then we're going to have x plus or minus some number, and then x plus minus some other number, maybe could be the same, could be different, right? So that's our goal. Our goal is to find out this m and n so that we can have this factored. So the fastest way, the way that it's structured and easy, I would say, is to always find factors of c, and then just look at the list and see which of those factors would add into b. So the steps would be: find all factor pairs. I'm just going to move this a little bit because I need to say of c. So find all factor pairs of c, and then in the list above, find the pair adding to b. So two factors which satisfy 1 and 2 are, right, so two factors, numbers, which satisfy conditions or steps, satisfies steps 1 and 2 are m and n. So that's the procedure. It looks a lot when you have these numbers, but in reality it's a joke. So we need to factor 6. So what are all of the factors that we can get for 6? When 1 times 6 makes 6, 2 times 3 makes 6, and there is nothing else. I mean, you can go 3 and 2, but that's the same as the previous one. Then 4 doesn't work, 5 doesn't work, 6 is again 6 and 1. So that's it. We just have two pairs, 1 and 6, and 2 and 3. So hopefully you see that 2 plus 3 is 5. So step number 1 is to create this list. And step number 2 is to see which pair adds to 5. Well, this pair adds to 7, and this pair adds to 5, so that's the pair we're looking for. So the solution is x plus 2, x plus 3. And we're done. That's literally what the whole section is all about. Factor, but find all pairs, right? Don't be lazy, because some problems are tricky, especially when the minus signs kick in. So please factor all of the pairs, and then once you have the pairs, find the one that you actually need. Now, if you let's say you care, right, and you want to check, well, you just FOIL this, and if you get the original problem, you're good to go. So that's x squared plus 3x plus 2x plus 6 gives us x squared plus 5x plus 6. So it works. Let's take a look at 1,000 other examples, literally, because we need it. X squared plus 9x plus 20. You immediately create the factor tree for 20. You always start with 1. 1 times 20 is 20. 20 is even, so it's divisible by 2, so let's use 2. 2 times 10 is 20. 3 doesn't divide 20, so don't worry about it. 4 does, gives us 5, right? And so on. So now we created the list of all factors, right? This one adds to 21, this one adds to 12, this one adds to 9. Yay! So the answer is x plus 4, x plus 5. That's it. When you have all the plus signs, it turns out to be very, very easy. Let's see more. M squared plus 13m plus 36. M squared plus 13m plus 36. That's problem 27 in the book. We immediately factor 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't work because 36 is not divisible by 5, but 6 times 6. And these are all combinations, all of the pairs that will multiply into 36. And it's literally, you start with 1, it's always there, and then if the number is even, it will be divisible by 2, and the sum of the digits divisible by 3 will be divisible by 3. If the last two digits are divisible by 4, there are rules that you can memorize, or you can just go use a calculator and then look for whole numbers on the other side. Try 1, 2, 3, 4, 5, 6, until they reach the numbers that are the same or close by or so on. So now, which ones of these add to 13? This adds to 37, this adds to 20, this adds to 15, this one adds to 13. Yay. So the answer is m plus 4, m plus 9. That's the answer. Do the chart on the side, and you will be done with the problem in less than a minute. Because once you have all of the factors, you can quickly see which row adds to 13, right? And if you take a look, all of the other ones do not add to 13. You can have at most one. Let's do one more with all of the plus signs, and then we're going to kick in with the negatives. So, problem 30. Oops. It says n squared plus 52n plus 100. So what do we do? Well, same. Always the same. Immediately factor 100. 1 and 100. 2 and 50. 3 doesn't work. 4 and 25. 5 and 20. 6, 7, 8, and then 10 and 10. That's it. These are all factors of 100. Nothing else divides 100. You have divided by 1, divided by 2, divided by 4, 5, and then 10. You reach, when the numbers are the same, that means that you don't have to go past that, because if you try 11, 12, 13, 14, 15, next one is 20, but you already have 20. So we don't need to go any further. Once you reach the numbers to be the same, or numbers that are very close to each other, like 1 or 2 or 3 points apart, that means that on the next one they're just going to flip, and you're going to get the same pairs just in the other order. Since this is multiplication, it's commutative, there is no reason for us to find the other half of them. So what adds to 52? It is the second row. So our answer is n plus 2 times n plus 50. Now you can check one more time if you care, right? N plus 2, n plus 50. So it's going to be n squared plus 50n plus 2n plus 100 for n squared plus 52n plus 100, which is exactly what we were looking for. Now we are going to kick in with minus signs. So how do we solve these problems if there are minus signs? Well, let's just dig into it. So an example when we have a minus sign, right, could be, let's say, x squared plus x, or minus x minus, now let's do plus x plus minus 6. No, perfect. So now we have a minus sign. Now remember, when you are figuring out factors of c, your c is now negative, right? So you have to find factors of negative 6. And that is going to be 1 and negative 6, 2 and negative 3. But also, you can have negative signs on the first number and no negatives on the second number, right? So the numbers are the same, it's just the minus signs are on the first or on the second. So you need to have both now. So 1 times 6 is 6, 2 times 3 is 6, the next one will be 3, but 3 times 2 again 6, so we already have that. So there's no reason for us to go any further. So which one of these adds to plus 1? This one adds to negative 5, this one adds to negative 1, this one adds to positive 5, this one adds to 1. There we go. So the answer is x minus 2 times x plus 3. We are always factoring c, and then we look for it to add to b. Let's see. Another one with the minus sign. The minus with a negative c. 46 says m squared plus 4m minus 60. Every single problem always the same. Factors of negative 60. That's 1 and negative 60, 2 and negative 30, 3 and negative 20, 4 and negative 15. Again, you can do this on a calculator. 60 divided by 1, divided by 2, divided by 3, divided by 4, divided by 5, divided by 6, 7, 8, 9, 10 is a repeat already. So this is it. This is the list for negative 60. Now remember, when you have negatives, once you find it, you can also have negatives on the first number rather than the second number, right? So all of these could be negative, and then the other ones on the other side are all going to be positive. So now, which one adds to positive 4? So all of these will be adding to negatives because the second number, negative number, is bigger. So I just need to find over here which, there's the one. 10 minus 6 is 4. So m minus 6, m plus 10. M minus 6, m plus 10. And now we can have a negative sign. We can have two negative signs. Let's find the one with two negative signs. They all solve the same way. You just have to play with numbers. Here it says x squared minus 2x minus 80. That's problem 60. Again, we don't wait, no delay, right? Just 80 and the factors 1 and 80, 2 and 40. 3 doesn't work. 4 and 20. 5 and that's 160. 1 and then 35, 6. Okay, 16. 6, 7 and then 8 gives us 10. And oh, this was supposed to be negative, so we put negatives on all of these. Now I need negative 2. This already makes negative 2. I haven't even showed the other one. I already found my answer. right? So for sake of completeness, I will put the second chart as well. So when you have minus signs on the C, you would have two charts, right? One where the left numbers are positive and the one when the right numbers are positive. They have the same numbers. They have to have everything the same other than, you know, which number gets the negative. So your job is to factor completely, right? Factor C, and then use B, right? Because two numbers from C have to add, right? Two factors have to add into the value for B. So B value is -2, so that's 8 minus 10 is -2, so we're done. It's x minus 8, no, x plus 8, x minus 10. It's a very structured procedure. Just need to, you know, practice, and it will be, you know, it will be good. Let's take a look at another example. Can we factor everything? Of course not. So, you know, many of these problems are carefully crafted, right? So you can go in and, right, they're carefully constructed, and you can go in and you can do the calculations, right? But it doesn't work all the time for every problem. So those that are there for your homework and you know, and exams, they're, you know, for I use the word rigged, right, to work. But they don't have to, right? They will sneak in a couple of homework exercises and so on where actually you can solve it, and we call those prime. A squared plus 13a minus 42, right? This is problem 48. This one cannot factor. Let's take a look. -42, 1 and 42, -42, 2 and -21, 3 and -14. 4 doesn't work, 5 doesn't work, 6 and -7. And you have the other list where the other numbers are negative. It's the same chart, just copy everything and make sure you change the signs. Okay. So the question is, which one adds to 13? Nothing adds to 13. So this is -41, this is -19, this is -11, this is -1, this is +41, this is +19, this is +11, and this is +1. Nothing adds to 13. No pair adds to 13. So answer is prime. Prime means cannot factor. So you can run into problems that cannot be factored. Now see, if you're not working on these charts on the side, you'd be sitting there and beating you know, yourself into the head, saying like, whatever I think of, it doesn't work, but it should work. No, you write down, right? You write down all possible combinations for factors, and then you check them one by one. If they all fail, and you did the problem carefully, right, then you know that the problem is prime and it cannot be factored any further. Let's work more on negative signs. 62 says y squared minus 10y minus 39. So what should we do here? Well, immediately factors for negative 39. We need to think about these things, just do. So we have 1 and negative 39. 2 doesn't work because number is odd. 3 does work, gives us negative 13. 4, 5, 6, 7, 8, 9, 10, right? None of those divide into 39. So this is our list. Can we make negative 10? Of course we can make negative 10. That's negative 10 right there. So y plus 3, y minus 13. It's really, really structured, right? You learn the ways and then you go on. Now, we can combine this with greatest common factor from yesterday, and we can create, right, and then we can have also trinomials that have different leading coefficient, different than 1. So here's an example. Let's go with 5x squared. Let's say, give some kind of title over here. Converting. I want to say converting. Let's just say a different than 1. And then I say factor greatest common first, then you do not. So this is from 6.1. So here's an example. Say 5x squared minus 5x minus 60. Right? This over here is a problem. And we're going to deal with that one in section 6.3. But actually we don't need it. We don't need 6.3 here. What we need here is to realize that last class we learned about pooling the common, the greatest common factor. We remember that we are supposed to factor that in front of the whole expression. So now what I can do is I can factor out 5 from everywhere and get x squared minus x minus 12. So use 6.1 to factor out this term. So now I know what I need to do. I need to make a list for negative 12. That's 1 and negative 12, 2 and negative 6, 3 and negative 4, 5, 6, 7, and none of that stuff works. So there we go. That's our list. What makes negative 1? Last pair. So we have answer 5, x plus 3, x minus 4. And see this, we copy this 5 because that 5 doesn't impact what's happening in parentheses right now. Problem 78 is the spicy one. 6n to the 4th minus 18n cubed plus 12n squared. Well, we know we have to use 6.1 over here to begin with, because, well, there are two clues. One clue is that that's not a square, and the other clue is right here, it's not a 1, it's 6. So I should be able to pull GCF. Now, what is the GCF? Well, every number is divisible by 6, and every single one of them has n squared. So if I pull out 6n squared, we are left with n squared minus 3n plus 2. So we used 6.1 to transform problem into what we are used to, so we can use the method we just learned. So each one of these had a 6 times a number in front, therefore we can pull 6, and each term had at least n squared. So that's what's common, and it's the most of it, and it's common, and it's a factor because you see that you get 2 factors, right? So now that we have this, we can put our factor tree for 2. And that's just 1 and 2. So what now? Right? What now? Well, we need positive 2, but we also need negative 3 over here, right? Is there a way to create negative 3 out of this? Well, no, because the numbers are positive. But if they are both negative, they will still multiply into positive 2 over here, which is a requirement, but they would add to negative 3. So that's our pair right there. We have 6n squared, n minus 1, n minus 2. So in algebra, we should have 2 or 3 sections that rely on this, right? But you will use this much more as soon as you go to pre-calculus and calculus and so on. Let's see if we can find more of these where you have to factor. Here, problem 75. It says negative 2x cubed plus 6x squared minus 8x. All of the numbers are divisible by 2, which is great, and each one of these has at least 1x. So, when we factor, right, using 6.1, we're going to kick out negative 2x. So now, what are the leftovers? So how much is negative 2x cubed divided by negative 2x? Negative cancels negative, 2 cancels 2, and then you have 3 x's on top, 1 x on the bottom, 1 gets cancelled, so you just get your x squared. Then you have your 6x squared divided by negative 2x. 6 divided by negative 2 is negative 3. And then you just have x, because these are 2 x's, that's a single x, they cancel, and you just have a single x. And finally, negative 8 divided by negative 2 is positive 4. X's get cancelled in this division. And now we transformed our problem to a trinomial with coefficient 1 over here. That's very important. So we have negative 2x times, and now this is where the factors go. So what are my options to factor 4? My options are 1 and 4 and 2 and 2. Nothing else adds to the nothing else adds. Now this is problem 75. Yeah. All right. So in order to keep this positive and have a negative number there, we have to use 2 negatives. So we'll just write the other formula as well, the other chart that has these. So now, which one adds to negative 3? Well, this one adds to 5, this one adds to 4, this one adds to negative 5, this one adds to negative 4. None of them. None of the pairs work, which means we're done here. Cannot factor further. Because nothing worked from these lists, right? We need them to add to negative 3. It did not add to negative 3, right? I added to positive 4 and positive negative 4 and positive negative 5. So some problems, right, you are going to be able to do the GCF part and then it's not factorable. Y squared minus 2y plus 3. So here's another problem. And for this one, right, factoring over 3, right, is easy. 1 and 3, and then it's not divisible by 2, so you can't do anything there. But 3 can also be written as negative 1 times negative 3, right? So which of these add to negative 2? Well, this one adds to 4. And this one adds to negative 4. So none of them again. So you would say prime, i.e. cannot factor. Alright, so let's take a look at situations. So we have x squared plus bx plus c. So get your list for c and then find the pair adding to b, right? So that's the list. We can have x squared plus bx minus c. Well, now you are looking for negative c, and then you copy it for negative c, just put the signs on the other numbers. So if you have your 1 and c right over here, 1 and negative c, then this one will be negative 1 and c. Going down. So you try 1, try 2, try 3, 4, 5, just keep going. And then you can keep populating the other chart backwards. I mean, the minus signs. And then again, find the pair that adds to B. Right, and finally the tricky one. So this is like a formula summary or something. Finally, we have x squared minus bx plus c. Well, when you factor your c's to 1 and c and so on, you also have negative 1 times negative c, making the same, right, using the same numbers and opposite signs. But both of them have to be minus because, remember, c is positive. So both of them have to be minus. So this is like a little bit of a summary chart of what to do when you see the problem. Working on these charts, right, and having these charts, so it's insanely important to have them. So please make sure you have that. And yep, that's it. That's it for 6.2. Please make sure you have these charts, and when you have the charts, it is easy to spot the pair that you need to use. You see that every problem that I worked out today had the chart, right? So, you know, make sure you have those charts. And that's it for 6.2. we will be back next week. So there will be no new lecture on Friday, Saturday, Sunday, obviously. Please make sure you're keeping current with the homework on my MATLAB, and announcements in Canvas, where I will post about exam 2, exam 3, and so on. We have only 2 sections left for exam 3. That's it. We just need to do 2 more sections in chapter 6, and then we are done with 5 and 6, which are the 2 chapters for exam 3. So I will see you all soon. Bye.